Hello and welcome back to Elementary Algebra. I am your instructor, Amy Fuchsteiner, and today we are going to be working on solving quadratic equations. We are going to be using the zero product property or the zero factor property today. If you're watching this video, I may not need to remind you, but just a reminder that there are other methods, and those other methods will not get you full credit. We are asking you to add a tool for factoring and to demonstrate that you can use the zero product property to factor. So please make sure you are using this method when requested. All right. To begin, we are going to define what a quadratic equation is. The equations that we have solved thus far in this class have all been what are called linear equations. That is, they are degree 1. They have x to the first power or whatever variable that may be. Today, we have enough background that we can look at how to start solving what are known as quadratic or degree 2 polynomials. Some examples of degree polynomials are found below, but what you need to know is that second degree polynomials are polynomials where the x is to the second power. The variable is to the second power. As such, that means that you could have two different solutions to each problem. So, what am I saying? The quadratic equation is a degree 2 polynomial. As a degree 2 polynomial, there are up to, not necessarily always, but up to 2 solutions. All right? We will recognize a quadratic equation by looking for its standard form. The standard form of a quadratic equation, you've seen it a lot, is ax squared plus bx plus c is equal to 0. You've seen ax squared plus bx plus c several times. You may already be familiar with that, but we're going to say that it's an equation. So in order to have an equation, it must be equal to something. In standard form, that is ax squared plus bx plus c is equal to 0. Below, I have 4 examples of equations, and I'm asking you to determine whether or not they are quadratics, right? So, remember, ax squared plus bx plus c is equal to 0. If I have 25x squared minus 16 is equal to 0, is that a quadratic? Well, we've said it's ax squared plus bx plus c. We've said it has to have 3 terms. Does this one have 3 terms? While it does not demonstrate 3 terms, what if? What if I rewrote this as 25x squared plus 0x's minus 16 is equal to 0? Is that all right? Does it have the same value? Yes, it does. Is it a degree 2 polynomial? Yes, it is. This is a quadratic equation. I do have an ax squared, I do have a bx, and I do have a c. Just because that b value would be 0 doesn't mean that it's not a quadratic, right? If I'm looking at problem number 2, I have x squared plus y squared plus 2xy minus 5. Is this a quadratic? Does have that sort of ax squared plus bx plus c. Does have that 1, 2, 3 terms in it. It is set equal to 0. But the problem is that if we look at this term, x squared and y squared, this term is degree 4. Right? And as a degree 4 term, it would not qualify as a quadratic. A quadratic needs to be degree 2. This is degree 4. So that means it's not a quadratic. I have 6y squared plus 8y minus 5. Is this a quadratic? Yes, it is. The fact that there's y's there instead of x's doesn't make any difference. This is a quadratic for sure. All right, I have number 4, which is 1 minus 3x cubed is equal to 5x. Is this a quadratic? No, it is not. And it's not a quadratic for one reason only. If I were to put this in order, I would have a negative 3x cubed minus 5x plus 1 equal to 0. It's not a quadratic because it's degree 3. The fact that it's equal to 5x is not what's throwing it off. I can rearrange stuff. It's actually the fact that the power there is 3 and not 2. And for a quadratic, we need a degree 2 polynomial, right? Okay. As such, as a part of that recognition, sometimes you're going to get polynomials that are not in the proper order. So we want to make sure that you can rewrite quadratic equations into standard form and identify the values of a, b, and c. Remember, the order is ax squared plus bx plus c equals 0. Okay? So here I have 2x plus 5x squared minus 4, or equal to 4. So the first thing I'm going to do is I'm going to subtract that 4 over. So I have 2x plus 5x squared minus 4 is equal to 0. Now, once I have that subtracted over, now I can reorder the side. The 5x squared should come first, the 2x second. So this would be 5x squared plus 2x minus 4 equals 0. I want to be clear that this is a plus 5x squared plus 2x minus 4. I did not just swap those and leave the sign. The sign in front of that 2 is positive. So I'm moving the 2x with the plus sign that is not written in front of it, but is in front of it. The 5x keeps the plus sign in front of it, but we don't normally write it when it's lead. So that's where that's coming from. Based on this writing, can you identify the a, the b, and the c? The a is the coefficient of the x squared. The b is the coefficient of the x. And the c is the constant, which would be negative 4. Right? Similarly, I'm changing back to my black one. Changing back to the black marker. I just like it better. Similarly, this is not in order. I need the 13q and the 4 moved over to the other side with the q squared. So this is going to be q squared plus 13q, because I'm going to add that to both sides, plus 4, because I'm going to add that to both sides, equals 0. It is in order. So now I can say that a is equal to 1. B is equal to 13, and C is equal to 4. 7m squared minus 5 is equal to 3m. I'm going to move that 3m over by subtracting it. So I'd have 7m squared minus 5 minus 3m is equal to 0. In terms of order, the minus 5 and the minus 3 need to be switched. So I'm going to reorder this to 7m squared minus 3m minus 5 equals 0. Then from here, I can tell that the A is equal to 7, the B is a negative 3, and the C is a negative 5. Last one for reordering, number 8. I have a 1 minus 3x squared is equal to 5x. So I'm going to subtract that 5x over. I'll have 1 minus 3x squared minus 5x is equal to 0. This is the wrong order. That 1 needs to come after the 5x. So this is going to be a negative 3x squared minus 5x plus 1 is equal to 0. Do you see how I kept the sign in front? There was a minus in front of that 3x squared, so it stays a minus 3x squared. There's a minus in front of that 5x, so it stays a minus 5x. And that 1 has an invisible plus sign, so it becomes a plus 1. This gives me A is equal to a negative 3, B is equal to a negative 5, and C is equal to 1. All right? Okay. Can we solve some quadratic equations using what's known as the zero product property? My assumption is that you do not know what the zero product property is. So let me explain. The zero product property comes from the great, well, no, it doesn't come from it. Okay. So the zero product property basically says if A and B are both real numbers and you're multiplying those two numbers together and you get 0. So I'm thinking of two numbers. There used to be a Johnny Carson bit. I'm thinking of two numbers. And when you multiply those two numbers together, you have to get 0. What can you tell me about those numbers? I'm thinking of a number, and when you multiply it by 0, you get 0. What does that mean about my number? Well, it means my number can be anything. But if I've got two numbers and I multiply them together to get 0, then either the first number has to be 0 or the second number has to be 0. Can they both be 0? Sure. But at least one of them has to be 0, because the only way you can multiply something to get 0 is if you're multiplying by 0, right? So we use this particular fact to create small equations that we can solve. So if I have two factors, if I have x and an x plus 1, and when I multiply them together, I get 0, this means that either x has to be 0 or x plus 1 has to be 0. So one of the factors, maybe both, has to be 0. If x is equal to 0, I'm done. That's it. But if x minus 1 is equal to 0, then I will subtract 1 from both sides. And x could be a negative 1. This means the solution set to this is 0 and negative 1. So if I put a 0 in, 0 times 0 plus 1 is 0. That checks. And negative 1 times negative 1 plus 1 is negative 1 times 0, which is still 0. That also checks. So my solutions are that x could be 0 or a negative 1. We sometimes write this as x equals 0, comma, negative 1. We may also use the solution set of 0, comma, negative 1. This is sometimes how you see the set notation. That little curly brackets is a set notation. All right, similarly, if b plus 5 times b minus 2 is equal to 0, then either the b plus 5 has to be 0 or the b minus 2 has to be 0. If the first part is true, then I can add 5 to both. I can subtract 5 from both sides. And we see that b is equal to a negative 5. If the second one is true, I would add 2 to both sides. And our value of b, to make the equation true, would be a 2. So I'm seeing that b is a negative 5 or b is 2. I would then want to check this. To check this, I would have negative 5 plus 5 times negative 5 minus 2. That's 0 times a negative 7. That's 0. It checks. I would also check the 2. 2 plus 5 times 2 minus 2. Or 7 times 0, which is still 0, and that checks. Both of these solutions work. So they are both possibilities for my answer. I can write this as b is equal to negative 5, 2, or I can use the solution set notation of 5, comma, negative 5, comma 2. Both of these are valid ways to write the answer. Right? Kicking it up slightly, I have one factor of 2x plus 3 and a second factor of x minus 7. When I multiply them together, I get 0. Just the fact that these two factors together give me 0 means that then either the 2x plus 3 has to equal 0 or the x minus 7 has to equal 0. If the 2x minus 3 is equal to 0, then to solve for x, we will subtract 3 from both sides and divide by a 2. That gives us one possible solution. If it is the second factor and x minus 7 is equal to 0, then I can add 7 to both sides to note that x equals 7 will also zero out my factors. To check this, I would do 2 times a negative 3 halves plus 3, which is a negative 3 plus 3, which is 0, times a negative 3 halves minus 7. I don't know what that is. And that's okay. I mean, I do know what that is. But if you don't, you do negative 3 halves minus 7, and you get a negative 8.5. But it doesn't matter, because when I multiply that by 0, I'm still going to get 0, right? Because I got a 0 there. So 0 times anything is still going to be 0. So I know that the negative 3 halves works. What about the 7? So that would give me 2 times 7 plus 3 times 7 minus 7, or 17 times 0, which is still 0. So they both work. So my x value here could be a negative 3 halves, or it could be a 7. So we'll solve that as a negative 3 halves comma 7. Okay. Problem number 12, I still have two factors. When I multiply those two factors together, I get 0. So either the first factor is 0, equals 0, or the second factor is 0. If the first factor is 0, to solve for the m, I will add 1 and then divide by 5. For the second factor, I will subtract 7 and divide by 2. So these are my two possibilities. If I want to check them, I can put them in. I'm going to use my calculator for this one. I'm going to do 5 times 1/5 minus 1. And that's going to give me 0 times whatever this is. 2 times 1/5 plus 7. Oh, I don't need that. Okay, times 7 and 2/5. And that's 0 times some awkward fraction, which is still going to be 0. So the 1/5 works. And then if I do m as a negative 7 halves, so I'd have 5 times a negative 7 halves minus 1. So that's going to be a negative 18.5 times 2 times a negative 7 halves plus 7. Whoops. That's 0. Anything times 0 is 0, so that one works. So my m value here could be a 1/5 or a negative 7 halves. Okay, good. That's the zero product property. If two things are being multiplied together to be 0, either the first part is 0 or the second part is 0. When we're doing our algebraic factors, those could be very simple statements like in number 9, and they're just really quick to figure out what the zeros are. Or they could be a bit more complicated like in number 12, right? So the important part is that you understand how we're getting to these answers, right? How we're getting that x could be 0 or negative 1. Because as you move through this, you'll see that there is a little bit of a pattern here. And sometimes if we get to the pattern, we forget the process behind it. But we want you to understand that we're giving each factor, each little algebraic parentheses, a turn at 0. And then we're solving that little mini equation, right? Okay, so we are going to kick this up even one place higher, and we are going to start solving equations by using this factoring. So we're going to use this idea of the zero product property to solve our equations, right? As I say this, yes, there are other methods, and if you use Google and you use one of those other methods, you will not get full credit on this, because I am checking to see if you understand the zero product property. If you use a different method that is not the zero product property, you will have the correct answer. You could get the correct answer at least, but you are not demonstrating what has been asked for, which is the zero product property. I hope we're clear on that. Okay. All right. So when we solve a quadratic by factoring, I've written out the steps here because I feel like it's important and you may want it as reference. So the first thing we're going to do is make sure our equation is in standard form. Then we're going to factor that quadratic equation completely. We're going to use the zero product property and set each factor to 0, solving the mini equations that result. Then we're going to check our results in the original equation to make sure that they work. Now, we're a little spotty on checking the results. I get that. I get that. It takes a lot of time. But we're going to demonstrate it anyway. All right? Okay, so we're going to solve by factoring. And I would like for you to be prepared to explain your process as you go. That means when you do the test on this, you're actually going to be asked to explain your process. Good? Right. Okay, I have a 15x squared minus 25x equals 0. This is not technically in standard form, so I'm going to put it into standard form. I'm going to take out, well, actually, no, I'm good. It is in standard form. I'm going to look at this and I'm going to see, okay, I can pull a 5x out. If I pull a 5x out, I'm left with a 3x minus 5 equal to 0. It is fully factored. Since I have a 5x and a 3x minus 5 as my two factors, it must be true that either 5x is equal to 0 or the 3x minus 5 is equal to 0. If the 5x is equal to 0, then x would be 0. If the 3x minus 5 is equal to 0, then to solve this mini equation, I will add 5 and divide by 3. So I have two possible solutions here. I have, could it be that x is 0, and could it be that x is 5/3? Either one of them could work. So to check, first I'm going to check 0, and that's going to give me 15 times 0 squared minus 25 times 0. That's still 0. It checks. And then I'm going to check the 5/3. So that will be 15 times 5/3 squared minus 25 times 5/3. This is where the calculator comes in handy. 15 times 5/3 squaring it minus 25 times 5/3. And I got 0. So my solutions here are that x could be 0 or 5/3. All right. What do I do about number 14? This is k squared is equal to 49. I want to write it in standard form. To put it in standard form, I will need to move the 49 over to the other side. I have k squared minus 49. This is two terms. It should be factorable. K squared is a perfect square. 49 is a perfect square. So k times k and 7 times 7. This will factor into a k plus 7, k minus 7, equal to 0. And once I have those two factors, I know I'm done because it's degree 1, degree 1, right? Either the first factor is 0 or the second factor is 0. So k would be a -7. I'm subtracting 7 from both sides. For the other one, I am adding 7 to both sides, or k is equal to a positive 7. I want to check both of these answers by putting them into the original equation. So if I have a -7 and I square it, do I get 49? I do. And if I have a positive 7 and I square it, do I get 49? I do. So my answer here is k is equal to a -7 or a 7. All right, let's try problem number 15. Problem number 15 is already in standard form. X squared minus 2x minus 35 is equal to 0. So now I want to see if I can factor this trinomial. All right, I like the grouping method. Maybe you see a different method. That's fine. I could do this one by mental math. Maybe I'll do mental math. I'll do mental math on this one. So if I'm doing mental math on this one, I want the two factors that multiply to a -35, but add to be a -2. And for me right away, I see that that is going to be a -7 and a +5. So if I'm using mental math on this one, that's going to be an x squared, which is going to be an x and an x. And I know I need a -7 and a +5. Yeah, mental math is nice on this one. All right, so once I have the two factors, this would be an x -7 is equal to 0 or an x plus 5 is equal to 0. I can add 7 to both sides. That's going to give me x is equal to 7. And I can subtract 5 from both sides. So I have x is equal to a -5. If I'm going to check them, I want to check them in the original equation. So this is going to be 7 squared minus 2 times 7 minus 35. 7 squared minus 2 times 7 minus 35. Okay, that's 0. That checks. And I want to also check my answer of a -5. So that's going to be a -5 squared minus 2 times a -5 minus 35. I'm going to do this one by hand. -5 squared is 25. -2 plus 10 minus 35. Yep, that zeroes out. So my answer here is that x could be 7 or a -5. Two possible solutions. And keep in mind, we're getting two possible solutions because that's squared. I should have up to 2 solutions. I have 2 solutions. I'm good. All right. Problem number 16, still solving here. We want to put it in standard form first. So I've got a squared minus 4a plus 4 is equal to 0. And then we want to completely factor this. So a squared minus 4a plus 4 is a trinomial. I can factor by grouping. 4 times 1 is 4. It's a 1 in front of there. What factors of 4? It's a positive 4, right? So it would be 2 and 2 or -2 and -2. So I'm going to do this as a squared minus 2a plus 4. Taking a out of the first grouping, I have a minus 2. The second grouping, I can pull a 2. I'm going to pull it negative because there's a negative in front. So that leading negative tells me to pull a negative as well. And then I have a minus 2. So I have a minus 2 in both. A minus 2. A minus 2 is equal to 0. Oh, it was a perfect square. And I didn't recognize it. That's okay. If you don't recognize it right off bat, you can still get to it, right? This was a perfect square trinomial. I didn't recognize it right off the bat, but using the grouping method or even the mental math method, I would have still been able to see in the end that this is a minus 2, a minus 2. So either a minus 2 is equal to 0 or a minus 2 is equal to 0. Each term, each factor gets a turn at being 0. So I would add 2 on both of these guys. And I get a is equal to 2 or a is equal to 2. Well, these aren't different numbers. This is the same number. I thought I was supposed to get 2 solutions. I did get 2 solutions. It's just it was the same one twice. This is why we say that we can get up to 2 unique or different solutions, because sometimes we get no solutions and sometimes we just get an a is equal to 2 and we get a singular solution. It just hit twice. This is a thing in math. This has a name because it happens often enough. This would be called what's known as a double root. And it's a double root because we got a equals 2 twice. So we've doubled the number of times we got that particular answer. So this is known as a double root. They do occur. They are not unicorns. They happen all the time. Okay. All right. A couple more to try. We'll just kind of keep going with some extra examples here. All right. So for problem number 17, we want to make sure it's in standard form. So I'm going to do an 8x squared. I'm going to add 2x. Subtract 15 equals to 0. Now, I did a little trickaroo here. I didn't just add 2x to the end. I actually put 2x where it was supposed to go between the squared and the not squared. And if you can make a slide like that sort of mentally, I encourage you to do so. I'm not trying to make you show every step every single time. But we are going to have to show the factors and using the zero product property here. So I've got an 8x squared plus 2x minus 15. This is a trinomial. There are 3 terms. 8 is not squared, so I know it's not a perfect square. 15 is not a square either. So I'm going to use my grouping method because it gives me a starting point. That's why I like my grouping. So I've got 8 times a negative 15 would be a negative 120. If you're not sure of that, you've got a calculator. You can use it. So 8 times negative 15. Yep, negative 120. Factors of a negative 120. Note that the middle term is positive. So one factor needs to be negative, one factor needs to be positive, as determined by having a negative 120. I know the positive will be bigger because when I added them together, I end up with a plus 2x. So I'm thinking ahead of myself here. So this could be a negative 1 and a positive 120, or a negative 2 and a positive 60, a negative 3 and a positive 40, a negative 4 and a positive 30, a negative 5 and a positive 24, a negative 6 and a positive 20, a negative 8 and a positive 15, 9 doesn't work, a negative 10 and a positive 12. You probably came to that way faster than me, but I wanted to show you that I do usually write out all of them because I have been known to jump ahead of myself. So this is the factor pair that will work. So this is going to be written as 8x squared minus 10x plus 12x minus 15 equal to 0. I now want to factor by grouping, so I'll pull the first group and then I'll look at the second group. In the first group, I can pull out a 2x and I'm left with 4x minus 5. In the second group, I see 12 and 15, I can pull a 3. Plus 3, and I'm left with 4x minus 5 equals 0. So I've got a 4x minus 5 times a 2x plus 3 equal to 0. So using the zero product property, I know that 4x plus 5 would be equal to 0, or the 2x plus 3 would be equal to 0. If it's the 4x plus 5, I'm going to subtract 5 from both sides. 4x would be a negative 5. Divide by 4. Or if it's 2x plus 3 that zeroes out, then I'm going to subtract 3 from both sides and divide both sides by 2. So I have solutions of x is equal to a negative 5/4 or a negative 3/2. I do have two distinct solutions. Okay, what do I expect you to show? Well, I expect you to go from here to show me how you get to here. There are different ways of doing it, but I expect you to show me how you go from the standard form to the factored form. And then I expect you to show me either the setup to the answer or each one of those solvings. You don't necessarily have to show me each step, but that you gave each one of them a shot at 0 and what you got for your x values. Okay? All right. Great. Problem number 18. Problem number 18 is very similar, but we've got to get it into standard form first. To do that, I'm actually going to multiply through because I got to get that. I got to add 25. So I'm going to do 3x minus 10. But now I'm going to add 25 to both sides because standard form is equal to 0. So now to make this a little clearer, I'm going to do 9x squared minus 30x plus 25. Okay. Can I factor anything out of that? I cannot factor anything out of that. All right. So I can't factor anything out. So 9 times 25 is 225. It's positive. That would be positive. Okay. So the factors of 225, they're either going to be both positive, because that's positive, or they're going to be both negative. I'm not sure which yet. Oh, yeah, I am. That's minus. Because that's minus, I know we're going to be both negative here. Okay, so I need both factors to be negative for 225. That's going to be 1 and 225. It ends in a 5, so 225 divided by 5, or a 5 times 45. That's not going to work. Okay. 10 won't work. Will 15 work? So let's do 225 divided by 15. Aha! 15 and 15. Dude, it's a perfect square trinomial again. Ugh, okay. I didn't recognize it. All right. 9 is a perfect square, so that's going to be 3x times 3x. 25 is 5 times 5. If I multiply them together, 3x times 5, that's 15x, and that's going to be, when I double it, I do get a 30. So this is going to be 3x minus 5, and a 3x minus 5 equals 0. Yes. Okay. So now I've got it set up so my factors are equal to 0. I have that 3x minus 5 is equal to 0, or it could be that 3x minus 5 is equal to 0. It's the same factor both ways. So 3x is 5 and x is 5/3. Same thing is going to work here. And so we get that x, oops, I didn't want that. X is 5/3. And we have, again, what's known as a double root. That's okay. Double root. 5/3 comes up twice. It's the same factor 2 times. Okay, great. Now, the second goal, or fourth goal, I guess it is, basically, they've just got a greatest common factor. It's not going to be a quadratic. Part of it will be a quadratic, but we're going to do third degree now. So I'm going to show you how to do these. It's maybe a bit too far, but I can spend 5 minutes on it. All right, so here's the idea. The idea is basically the same. You're still going to get everything over on one side. So we're going to have 6x to the third minus 11x squared minus 7x is equal to 0. And that in these cases, you will end up with a greatest common factor. I can pull out an x. And once I've pulled out that x, then the remaining factor here is a quadratic. So I will want to look at whether or not I can factor that particular quadratic, right? So 6x squared minus 11x minus 7. I'm going to do a times c. I'm going to look at a negative 42. And I want the factors of a negative 42 that will add to be a negative 11. God, I'm hoping they work. I'm hoping I didn't typo this. Okay, so a negative 42 could be a 1 and a negative 42. It could be a 2 and a negative 21. 3 and a negative 14. There's my pair that works. Okay, so this will be a 6x squared plus 3x minus 14x minus 7. Looking at the first group, I can pull out a 3x, 2x plus 1. Looking at the second group, I can pull out a minus 7, 2x plus 1. So the 2x plus 1 is in both. It can come out front to factor. And then we have 3x minus 7. Okay, bringing down my x from the greatest common factor. You see we actually have 3 things being multiplied together that give you 0. And so all we're doing is upping the ante here. Instead of just 2 things, 2 little equations, we end up with 3. So either x is equal to 0, or the 2x plus 1 is equal to 0, or the 3x minus 7 is equal to 0. Any one of these is an option. If x is equal to 0, that's fine. If 2x plus 1 is equal to 0, then 2x would be a negative 1, and x would be a negative 1/2. If 3x minus 7 is equal to 0, then I add 7 and divide by 3. And so I have 3 solutions here. X could be 0, a negative 1/2, or 7/3. Any one of those 3 is a possible solution. And this makes sense because remember when it was degree 2, we could have up to 2 solutions. This is degree 3, so we should expect up to 3 solutions. And that's what we got, 3, right? Because it was x to the 3rd. Similarly, with problem number 20, we're going to do the same kind of thing. We're going to get everything on one side, but I'm going to distribute first. 2x third is equal to 2x squared plus 4x. Right? I just distributed ching ching. I think I did that right. 2x squared, 4x. Yep. Now I'm going to move everything over. So I have 2x to the 3rd minus 2x squared minus 4x is equal to 0. I see I can pull a 2 out of everything, and I can pull an x out of everything. And that's going to leave me with x squared minus x minus 2. So now I want to see if I can factor this trinomial further. X squared minus x minus 2. So what multiplies to give me a negative 2, but when I add, I get a negative 1. I can use mental math on this one because that x squared can only be an x times an x. And then the pair that multiplies to give me a negative 2 but adds to give me a negative 1 is going to be a minus 2 and a plus 1. Once I have it factored, each term or each factor gets a turn at 0. So either 2x is 0, or it could be that x minus 2 is 0, or it could be that x plus 1 is 0. Solving each little mini equation, dividing by 2, x would be 0. Adding 2, x would be 2. Subtracting 1, x would be a negative 1. So my solutions here are x could be 0, 2, or negative 1. Now, every now and again, you'll meet up with somebody who wants these in order. Just remember that if they've asked for it in order, to please give it give your answer in order from lowest to highest. Okay? All right. There's a lot in this particular section. So if you have any questions or concerns, please don't hesitate to reach out. We are all happy to help. I'm available by email, or you can call or text my Google Voice number. I will answer that as well. And next section is applications. So before you go for notes on that one, make sure you got a snack ready. All right? I'll see you in a bit. I'm probably not even going to change my sweater. Bye.